What is up, amigos? Today we're looking at how front wheel, rear wheel and all-wheel drive affects the aerodynamics of a car. We're going through the center of gravity and how that affects the aerodynamics, as well as the different transmission and the gearboxing, etc. So let's talk about the front wheel, rear wheel and all-wheel drive and the center of gravity first. Let's say we have a car going along the road and we have the free stream velocity coming in here. We're looking down on top. So we can either have a front wheel drive, a rear wheel drive, or an all-wheel drive. And let's say we have the wind is actually coming at a bit of an angle. So you can decompose this vector into two parts, the free stream, like the head-on one, and then the side one. And if we have a front wheel drive, it usually means that we have a lot more of the drivetrain assembly up front. That means that the center of gravity will usually be more at the front compared to the rear wheel drive, which will be more towards the back, and then the all-wheel drive, depending on how we have the transmission and the axles, etc., it could be somewhere in between. Now let's talk about just the front wheel drive. If we have a side wind, it's going to hit the entire vehicle side, and we're going to have a resultant force, let's say here. Now, the only difference between the front wheel, rear wheel, and all drive is just, let's say, the center of gravity. If we have the front wheel here and the side force is here, we're going to now produce a moment this way, which means that the entire car is trying to actually turn into the side wind. And that means that we have a less of a yawing moment between this angle, this vector here, and the car's center here. So this is actually a restorative moment. So it reduces how much that the car will actually start to want to turn. The more it turns, the less it wants to turn. Alternatively, let's say we have the rear wheel drive setup and we have the center of gravity back here. And this is exaggerated, but we're just doing it for visual effects. We have the force acting at the exact same point with the exact same wind, etc. What's happening now is we have this moment going back. So the car is actually trying to turn away from the wind, which then increases the effective angle of attack between this vector and the car's center here, which then increases the amount of side force we have, increasing the moment, and so on and so forth. The car wants to turn more and more. So it's actually exacerbating this problem. That all comes about just due to whether we have more of the assembly upstream or downstream, and consequently front wheel drive and rear wheel drive. Let's move now into the axle, the transaxles, the cooling, and the diffuser. So let's say we have the car and we're looking from the side now, and we have the wheels here. Just a simple setup here. And we can have, let's say, the front wheel drive. If we have the front wheel drive, we'll have the motor often up front, we'll have the transmission, etc. up front, everything quite centrally located to the wheels. So that means, again, we have a lot of the stuff that's controlling the car all up here, which means that at the back here, we can actually have quite a smooth underbody because we don't have anything here protruding out into the flow. What's more, we don't have these objects that need to be cooled, for example, the transmission, because it gets quite hot, the gears in there. So if we have it upstream, it means that the diffuser back here, as the flow comes along, it might hit this part and it'll get turbulent, it gets chopped up, whatever, but then it'll start to reattach and become a little bit more well behaved before it hits the diffuser. That means that the diffuser can now work much more effectively. Alternatively, if we have, let's say, a rear wheel drive, we often have a bunch of the mechanics downstream, including the stuff that's actually protruding into the flow, which means that we have cooling flow hitting it all the way back down here. So by the time we get to the diffuser, the flow is very chaotic, and that means the diffuser can't really work very well. So that's a major difference between the front wheel and rear wheel drives, and how the components where you locate them affect not only the center of gravity and the resulting side forces and whether it wants to restore that moment or not, but as well how the rest of the car can actually work in terms of aerodynamics. So that is the end of this video. If you liked it, make sure to like it and give it a thumbs up. And if you want to get better at automotive aerodynamics, check out a course that JKF puts on. It's really nice. It goes through theory and practice, and it goes through motorsports in a lot of detail. If you like what we go through here, you'll really like what they go through there. So you can check that course and link in the description. And I'll see you soon. Peace out, amigos.